Hello, thank you for watching this video. So in this video, I'll be doing question 2 of November 2022 question paper, Mathematics paper 2. And this is the analytical geometry. So I'm going to read the statement of question 8, which has this diagram here, and then proceed to answer the questions that follow. So let's read question 3. In the diagram, A, B, and C are vertices of triangle ABC. So in this diagram here, A, B, and C are the vertices of this triangle. This is what they say. T is the midpoint of CB. So this point T is a midpoint of CB. This is what this means. Let's continue. The equation AC is 5x minus 6y is equal to 8. So the equation of AC, here is AC, is 5x minus 6y equal to 8. So this is the equation of this line here. The angle of inclination of AB is alpha. So the angle of inclination, here is the angle of inclination of the line AB is alpha there. So here's your A, here's your B. So the angle of inclination with the axis is alpha. Triangle DCT is drawn such that CD is parallel to BA. The triangle DCT is drawn here, this triangle DCT, such that CD, this line here, is parallel to BA or AB, this line here. The lines AC and DC intersected S. So the line AC, which is this the line here, and this line here, they intersect there at S. At S, the y-intercept of AC, and this S of yours is the y-intercept of AC. So they are saying the lines AD and AC intersect at S, which is the y-intercept of AC, which is the line there, that one. So P, F, and R are x-intercepts of DC. So, where is it? P, F, and R are x-intercepts of DC, AC, and AB. So, P, F, and R are intercepts of these lines, which is the DC, AC, and AB respectively. So, these are the x-intercepts of these lines, as you can see here. Yeah, this is pretty much all of it. So this is all your statement. I think I've broken it down already. So I'm going to answer the questions that follow from question 3. So 3.1.1. Calculate the gradient of AB. So they want to calculate the gradient of AB. They want to find the gradient of AB. Let me get the calculator. So to find the gradient of AB, you know, gradient of AB is equal to what? Y2 minus Y1, or X2 subtract X1. So M of AB is equal to what? Y2, which is, what is our Y2? You can say this is point number 1, this is point number 2. So your Y2 is minus 4, minus Y1, your Y1 is 2. Divide by X2, which is 6, minus X1, which is what? Which is 4. What do you have? You have your M of AB is equal to minus 6 over 2, which is equal to minus 3. So this is your gradient of AB. So M is equal to minus 3, which is the same as that one. M is equal to minus 3. Because you are told that these AB and CD are parallel, which means they have the same gradient. The slope is the same, which means even this angle of inclination here should be equal. This angle here. Yeah. So you have your gradient, 3.1.1. 3.1.2. What does it say? Calculate the size of alpha. So they want to calculate the size of this angle here, alpha, which is the size of that angle here. So you know that to get the gradient of this line, it's a tangent of the angle of inclination. So you know that m of AB is equal to the tangent of what? Of your angle alpha there. So you know what your thing is. Your gradient is -3. It's equal to tangent of alpha, right? And then so you find the reference angle, which will be arctan 3. So what is it? So you take arctan of this of 3 there, which is, say, shift tan of 3, which is 71.57 degrees. So this is the reference angle, this one, reference angle. So, but we want the quadrant where tan is negative. So that is what? The second and the fourth quadrant. So we know that this angle here is an obtuse angle, which is greater than 90 degrees, this angle here. Same angle as that one, same thing, because this angle is the same as that one. So second quadrant, say alpha, is going to be 180 minus 71.57, which is equal to 180 minus 71.57. So it's 108.43. So the other possible position where tan is negative is the fourth quadrant. So 360 minus 71.57. So 360 minus 71.57. So it's 288.43, right? These are two possible values of alpha, right? So when you look at that angle, it is greater than 90, yes, but it is less than 180 because it doesn't even doesn't even complete 180 round to get to the line again. So this is not possible. So our angle of inclination is this one here. So our alpha here is 108.43. So it's 108.43, the alpha, which is the same as that, 108.43. So we have our angle of inclination. We're done with this one. Calculate the coordinates of T. What is T? T is the midpoint of these 2 points, right? So to find the midpoint of T, so it's 3.1.3. Coordinates of T, which is the midpoint, you know that midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. That's your midpoint. So what is our midpoint is T. So T, x1, you can say this is 1 and say this is 2, which is minus 2 plus 6 all over 2. And what? And minus 3 and minus 4, which is minus 3 plus minus 4 all over 2. So the coordinates of T are what? This and that is 4 divided by 2, that's 2. This and that is minus 7 over 2, so it's minus 7 over 2. So these are the coordinates of what? Of T. Because you're going to add, just add this and this, which is minus 4 plus minus 6, that's 4. Then divided by 2, that's 2. This and that's minus 7, divided by 2, minus 7 over 2. Those are the coordinates of T. you are done with this. So you go to 3.1.4. 3.1.4. What are they saying? Calculate the coordinates of S. They want you to find what the coordinates of S are. So the coordinates of S are on the line AC, right? So you can play around with the formula. You can say, okay, it's on the equation of, it's on this line, right? So you can solve your y here. Solutions, your 5x. Can solve your y here. So 5x minus 8, transpose the 8 to this side, transpose 6y to that side is equal to 6y. Then divide by 6, divide by 6, divide by 6. So what do you have? You have your y is equal to 5 over 6 x minus 8 over 6, which is 4 over 3. So this is the equation of what? Of AC. So we want the coordinates of S. We know this is the y-intercept. So your line is crossing the y-axis here. This line AC is crossing the y-axis. We know x is 0 on the y-axis. So we're going to substitute with the value that we know there to find its corresponding y value. So we'll say, okay, we have what? Y is equal to 5 over 6x minus 4 over 3. So it's y, but we know that x is equal to 0 there. So y is equal to 5 over 6 and 0 minus 4 over 3 is equal to minus 4 over 3. So the coordinates of S, we know the x coordinate is 0 and the y coordinate is 4 over 3. These are the coordinates of S. So you can put them, you can add them here. You can say, okay, here's our S, we have 0. Our y coordinate is minus 4 over 3, minus 4 over 3. These are the coordinates for S. So we're done with 3.1. Okay, 3.2. Determine the equation of CD. They want you to find the equation of CD. So in the form y is equal to mx plus c, y is equal to mx plus c. That is what they want you to find. The equation of what? Of CD in the form y is equal to mx plus c. M is your gradient. You say that this one, CD, is parallel to AB, which is they have the same gradient of minus 3. So you know that y is equal to minus 3x plus c, right? And then you need just 1 point now to find the value of c. You do have the 1 point which is at c. To be what? To be c is equal to minus 2 and minus 3. So now that we have 1 point, we can substitute the y and x to find the value of c. Our y is equal to minus 3 is equal to minus 3 times x, which is minus 2 plus c. So minus 3 is equal to this and this. This is positive 6 plus c. Therefore, transpose this to that side. C is equal to minus 3 minus 6, which is equal to minus 9. Therefore, your equation of a line is equal to y is equal to m, which is minus 3, x plus c, which is equal to minus 9. And you did this. So you have the equation of this line. Here is it. Y is equal to minus 3x minus 9. So you can add it here. And say, okay, the equation for this line now. Y is equal to minus 3x minus 9. And for this one, it's this one here. Okay? Let's go on. 3.3. 3.3. Calculate the size of angle C in DCA. They want us to find the angle C on DCA on this triangle here. They want us to find this angle here, right? So to do this, there are many ways you can do this. You can do it the hard way, right? So the hard way you can use the cosine rule, but it will take you forever, but it always works. I like it, the cosine rule, because you have the coordinates of all these points. Actually, you don't have the coordinates of D, but you have this line, and you can find the line here, because you have this point and you have that point. So you can find the equation of this line and find the coordinates of that point, which is the point of intersection, and find the coordinates of D. Once you have the coordinates of D, find the lengths of all these sides. Now, right? So when you find the lengths of all the sides, you use the cosine rule, because you will have all the sides as a squared is equal to okay, in this case, what will it be? You want this angle here, so it will be c squared is equal to the side, which is d squared, plus that side, which is a squared, minus 2dA cos c. This one will always work. So you find the coordinates of D. Once you find them, find the lengths of all these sizes, which is all these sizes. Once you have the lengths of all these sizes, now you're looking for your angle, which is straightforward. Because once you have the lengths, which is the hard part, just substitute all of them and you'll be left with that part, which you don't know. So you have the coordinates of this, find this length here. Oh, wait, sorry, find this length here, CD. So your CD is small letter d, which is this part. Find this length here. This length is small letter a, which is this part here. Find your c, which is that length over there, which is this part here, which is this part, also this part, you'll be left with that. You can solve for a. But I'm lazy to do that. I did that on the previous video. What was it? I think it was question 1 of November 2020, which has that question that have straight lines. I think it's question 5. If you can go to the, is it question 5? Yes, I think it is question 5. So if you can go to that question 5 of November 2022 mathematics paper 1, you'll find that I did find the area using this. I'm lazy to do it now. It's going to take me forever, and I don't have forever at this very moment. Okay, so what I'm going to do is I have this angle, which means I have that angle there, right? So since I have this angle, I can find this angle here, because these angles in a straight line, they add up to, angles in a straight line add up to 180. So if I have that, I can find what the missing part is. How am I going to do that? I'm going to say, okay, so I'll say alpha, or let's say this is P1 and this is P2. So I'll say angle alpha plus P2, angle P2, I call it 180. The reason will be angles in a straight line, right? They add up to 180. That's my reason for that. So I have that alpha is 108.43 plus angle P2 is equal to 180, which means that P2, angle P2 is equal to, transpose this side, so it's 180 minus 108.43. 180 minus 108.43. What is it? So it is, so this angle here, what is it? This angle here is going to be 71.57 degrees. So this angle here, and this angle here is 71.57 degrees. I have this angle. So because I have this gradient as well to be this, I can find the angle of inclination, this one here, and it will be equal to this one because of these are vertically opposite angles. So once I have this, I know the angles in this one. Once I have this, I will subtract the sum of these two from 180 because the angle in the triangle add up to 180. So I'll find this angle of inclination here. So let's say it's let's say is beta, this angle, right? Or let's say it's just angle F. So M of what? Of AC is equal to tan angle F. I'm saying it's angle. Is it F or S? S is this one, so it's angle F. So I'm going to say, what is this M thing here? It's 5/6 is equal to tan F. So F is equal to arctan 5/6. Right? So our F is equal to arctan 5/6. Arctan 5/6, which is 39.81 degrees. So this is this angle here, which is equal to that one. So I'll say this is F1 and this is F2. Actually, let me look at this. Yeah, so this is F2, this one. So let's say this is F1, that is F2, this is F1. So F1 is equal to angle F2. Why? These are vertical opposite angles. Right? So now I have a triangle that looks like this. I'm going to clean this part. So I have a triangle that looks like this. This, that, that. So I have 71.57, which is that part P2, P, and this is F. I have 39.81. So I want this part. So I know this is C. So I'll say, okay, what is this? My P2 plus F2 plus C equal to 180. So my reason would be, these are angles in a triangle. They add up to 180, right? So I'm going to clean 2.2 now. So P2 is equal to 71.57 plus F2, which is 30, what is it? Plus 39.81. So I have this part here, 39.81, which is the same as that one. 9.81 plus C is equal to 180. So your C is equal to, transpose the two, so you have 180 minus 71.57 minus 39.81. So you have 68.62 degrees. So this is your angle C. Then you're done with this one. Okay. What else? Calculate the area of POSC. They want to calculate the area of what? POSC. So I'm going to draw this part on the board separately. So I hope this part is clear. If it's not clear, you can pause it. I'm going to clean the board now. So I want to find the triangle, the area of that thing there. So I'm going to split this again. What do I do? So I'll start at P, so I have a P there. Draw it to here, O, and then put O here. And then you have the S is somewhere here, and then you have the C down here. And then what else? And then you have this guy coming down, which is here. So this is your P, this is your O, and this is your S, and this is your C here. So there are many ways you can look at this. You can look at it this way. You can say, okay, I'm going to look at this part here. So I'm going to look at this square here. If you look at this, this is a, sorry, not a square. This is a rectangle. So I'm going to look at this rectangle here. This is a rectangle here. This part. This is a rectangle. What else do you have? You have a right angle triangle. You can say you have a right angle triangle here. As you can see, this is vertical here, so this is a right angle triangle. What else do you have? You can say, okay, I have some triangle here. This triangle here. This is how you can look at this. So now what you're going to do, you're going to calculate the area of this right angle triangle, add it to this one and add it to this one. So this is how I would like to look at this thing. So what you have here, you have this angle here. You found it to be, what was it? 68.68. 68.68. This is what, this was your angle there. Let me add it because I didn't add it, now I forgot it. So 68.62, sorry. 68.62. This angle here. So you have 0 here. What do you have here? So you need to find the length of these sides and then you'll be able to find the area. So let me add this 68.62 here. 68.62 is this part here. So what do you do? So let's try to find the size that we don't have, right? So the coordinates of P, you don't know them, right? But you know the line that goes through P is this one, and that is the x-intercept. X-intercept. So you can find the value of the x-intercept. You know y is equal to 0 along this line. So your y is equal to 0. So your equation for that is y is equal to minus 3x minus 9. But you know this part is 0. So 0 is equal to minus 3x minus 9. Transpose 3x is equal to minus 9 divided by 3 divided by 3, which is x is equal to minus 3. So the coordinates of P is minus 3 and 0. So you have minus 3 and 0 here at P. Minus 3 and 0. So you have minus 3 and 0. So if this is minus 3 and 0, so the distance from this to that is 3 units. So all this distance here, from here to here, all of it is 3 units. This is what I can say. And then now, but you want this distance so that we can be able to calculate the area here, right? So you know the coordinates of S is 0 and minus 4 over 3. So the distance from 0 to this, 0 to S is 4 over 3. This is the distance. So the length of this is 4 over 3 from here to here, because it's this vertically downwards here, 4 over 3. What else? So you say, okay, I know my y coordinate here is what? It's 4 over 3. So this y coordinate, if you extend it here and it hits this line, you need to find the corresponding y value, because that's what we did. We extended this y value here and it missed this part. So you know that your y there is minus 4 over 3. So, and this lies on this line here. So if you know that y is minus 4 over 3, what is the corresponding x value. What is the x value that is sent to that y? So you want to find this y value here. So you have y is 4/3 here. So you want to find this y value. So you have 4/3. Sorry, you want to find this x value. You have 4/3 as y value here, and you want to find this the y x value. So you say, okay, I know that my y there at this point, let me say it's point k, this. My y at this point k, let me say this is k, let me say this is z, this point here. So you have z here. So you know your y coordinate there at point k is -4/3, right? And it lies on the line y is equal to minus 3x minus 9. So you have your y is -4/3. It's called minus 3x minus 9. So you find what is the x value. So transpose this. So you have -4/3 plus 9 is equal to minus 3x. Divide by minus 3, divide by minus 3. X is equal to -4/3 plus 9 all over 3, all over minus 3, right? So x is -23/9. So the corresponding x value here is -23/9. So this point here, -23/9. So which means from this point here to that point there, to this x value here, which has this y value, is -23/9. So the coordinates are -23/9 and -4/3. These are the coordinates for what? For k. So what that means is from here to that point is 23/9. So from this point to 0 is 23/9. So this is the distance from 0 to z. And you have this part here. You know what this is. It's 4/3. You know what this is, right? This length, you know this length is. You know what this angle is here. It was 39.81. And this one here, it was 71.57. So now, since you're saying, so what is 29.29/3? So it's roughly 2.5 what? 0.56 units. So if you're saying this all from O to P, if you're saying from O to P is 3 units and from O to Z is 0.5 units, which means the distance from here to Z here, which means this distance here to Z, this small distance here, is going to be 3 units minus 29.25. 3 units minus 2.56, so you'll get this distance here. So plus 3 units. So this is 0, or this is 4/9. So the distance between the two is 4/9, right? What else do you have? So you'll be able to find the area of this called half base times perpendicular height, and then here is going to be length times breadth. The area is, the problem now is on this triangle here. So it's going to be half this side times the angle between the two of them. So you need the length of this side as the distance between S and C. So distance SC or CS is equal to x minus x1 minus x2 all squared plus y1 minus y2 all squared. What do we have? We have the distance of SC to be x1, which is 0 minus 2 all squared plus the distance y1. What is y1? So y1 is -4/3 minus 3 all squared. So this is distance SC. is equal to that, square root of what? Of 0 minus 2 all squared plus minus 4 over 3 minus 3 all squared. So you have root 61 over 3. So the distance here is root 61 over 3, which is the same as that one. So now we can calculate the area of this thing now. How are we going to do this? I'm going to clean that one now because we have all dimensions that we needed. So what do we say? We say, okay, the area of this shape will be the area of triangle, will be the area of triangle, what? PZK plus area of our rectangle, plus area of the rectangle, what? It's P, okay, let me clean this, it's ZOSK. ZOSK plus the area of triangle KSC. So this is your area for what? For your entire thing now. This is your area for POSC. So this is your area for your entire thing. So we need to add these areas. So these areas are equal to what? Equal to area of the triangle, that one. So it's going to be half base. What is our base? It's 4 over 9 times our height, perpendicular height, it's perpendicular, so it's 4 over 3, plus the area of our, what is this thing? Of our rectangle, which is length times breadth, which is 23 over 9, times the breadth, which is 4 over 3, plus area of triangle KSC. So it's going to be half this side, which is 23 over 9, times this side, which is root 61 over 3, times sine of the angle between the sides, which is 39.81. Right? So you punch this in a calculator. What are you getting? So let's do that and see. So it's going to be 1 over 2 times 4 over 9 times 4 over 3 plus 23 over 9 times 4 over 3 plus 1 over 2 times 23 over 9 times root 61. Root 61 over 3 sine of this angle. So let me go and restart. So it's 1 over 2 times 4 over 9 times 4 over 3 plus 23 over 9 plus 4 over 3 plus 1 over 2 plus 23 over 4 plus this plus 1. That's 23 over 9 plus 4 over 3 plus 1 over 2 plus 23 over 9 plus root 61 over 3 sine 39.81. So your area of POSC is equal to 35 over 6. which is equal to what? 5.83 units squared. So this is your area of this thing, I hope. So we're done with this question. Let's go to the next one.